Hey everyone, we're going to spend a few minutes here kind of reviewing scientific notation. We use scientific notation a fair amount previously in chemistry. I know you guys use it in math, so this shouldn't be anything that's too difficult. We will get into a little bit as far as adding and subtracting numbers in scientific notation, as well as multiplying and dividing, and there's two special rules that will follow for that. But we're going to use scientific notation to express a lot of different numbers this year in physics, and we want to make sure that we have a good grasp on this before we move on. So if you have questions on any of this, make sure you raise them to me or to a classmate when you're in class. So scientific notation is going to encompass really large or really small numbers, and it allows us to write those really big and really small numbers that usually have lots of zeros preceding or ending the number in a much easier way. So scientific notation has a certain form to it, as we should know, and it consists of a number that has to be equal to or greater than 1. So it could be 1, it could be 1.0, but it's going to be equal to or greater than 1. And it has to be less than 10. Now we can represent numbers where the main part of our scientific notation is actually a number that is greater than 10, and we adjust our exponent accordingly. It's not standard scientific notation, but we can express the numbers in that way, just so you're aware of that. We follow that number by a multiplication sign. And we'll use a base 10 raised to some power. And that power can be positive or negative. So the general form that we'll see for a number in scientific notation takes the form a times 10 to the nth power. All the digits that are in a are significant. So in our original number, if we're converting into scientific notation, we want to make sure that we only put the significant digits represented by a. And if we're going from scientific notation to standard notation, that we adjust our number accordingly. For any number that has an absolute value greater than 1, we know that n has to be positive. So if we start with a number, let's say like 200, 200 itself only has one significant digit. So when we convert this number, we only want one digit in our notation. But we know that n has to be positive because this number here, 200, is greater than 1. So when we convert this, it becomes 2 times 10 raised to the second power. If a number that we're converting has an absolute value less than 1, we know that n is going to be negative. So it's indicating a small number. So if we were to start with something like 0.02, that's a number that's less than 1. We know that our n value has to be negative. So similar to the one above, this is 2 times 10 to the minus 2. So that's mainly what the exponent's telling us. Is the value of that number greater or less than 1? Make sure you're careful with your significant digits there. Now, there's a couple rules we can follow. If you feel comfortable just converting these numbers into standard notation and performing your operations, feel free to do that. These can be punched into the calculator as well, but oftentimes you have to do that carefully with your parentheses. We can also, if you find this manageable or easy. Once you do a little practice with it, it's really not too bad. It is an easy way to perform operations. So when we're adding and subtracting numbers in scientific notation, they have to be expressed in the same unit because we can't combine numbers unless they're in the same unit, and they have to have the same power of 10. So to start off here, first example, we want to combine 4.9 times 10 to the 4th and 5.7 times 10 to the 5th. First thing we check, they're in the same unit, so we're good there. And their power of 10 is to the 5th and to the 4th. So we can't really do that off the bat. So we have to convert one of these numbers so the power of 10 is the same. I'm going to convert 4.9 times 10 to the 4th here. And we'll move our decimal to the left. So this is going to make 0.49, and that's going to increase our exponent as we move farther away from the ones place, meters, plus 5.7 times 10 to the 5th meters equals. So now we can see that our exponents are the same. We still have our meters. We can simply add these together, and we get 6.19 times 10 to the 5th meters. Our two original numbers here each had 2 sig figs. So we want to only have 2 sig figs in our answer, so we'll round this off. That never switched back. So we would call this 6.2 times 10 to the 5th meters. When we multiply and divide, we're going to follow two different rules here for multiplication and division, but both very similar to each other. If we compare two numbers, we want to multiply them together, we're going to add their exponents together, and we'll subtract their exponents from each other when like bases are divided. So the general rules and the general forms here are listed, and I'll do an example for each one of these. So let's say we had the number 1.3 times 10 to the 5th grams, and we wanted to multiply that by 3.47 times 10 squared grams. Units don't have to be the same, but the units are going to multiply together as well, just like the numbers are. So we multiply these together. Since we're multiplying, we're going to subtract 5 and 2. So we multiply 1.3 times 3.47. We get 4.5 times 10 to the 7th. So we add those exponents together. We're multiplying. We also multiply our units, so a g times a g gets us grams squared. And there's our answer. So we multiply numbers in scientific notation. We're going to add their exponents together. Now if we wanted to divide two numbers, 8.4 times 10 to the 5th meters divided by 2.10 times 10 squared meters. Our exponents here, since we're dividing, we're going to subtract those. So we'll divide 8.4 divided by 2.10, which gets us 4.0. 5 minus 2 gets us the third power. And m divided by an m is equal to 1. So there is no unit listed here. 8.4 has two significant figures. So we want to make sure our answer has two significant figures as well. If you have any questions, make sure you raise them in class. Have a great day.